Hey, hi everyone. This is Vijay Pandey. So today we are going to talk about the Cisco ACI. Why Cisco ACI? What exactly we are solving in the infrastructure? What we are providing? Why we should purchase Cisco ACI? Right. Before starting the understanding the product, we should know that why we are doing this. Right. Let's take a look on that. So today I'm going to talk about the why Cisco ACI. Okay, we'll take a deep look, and these are the some uh, acronymous and definition. Like ACI full form is application centric infrastructure, which is Cisco product, and APIC is the SDN controller, which is policy controller, you can say, which full form is application policy infrastructure controller. And these are the some like two protocols, counselor of Oracle protocols. EP means endpoint, EPG means endpoint group. These are the some definitions which you will learn in a ACI course very frequently. And let's talk about why Cisco ACI. What is the current today's challenge we have, right? We have traditional network. Suppose you are working in traditional network, how you configure nowadays your each devices, right? You just log in each and every devices, you do manual configuration is. And also third thing is it's very hard to scale. Suppose you are deploying a 365 application, and nowadays the all modern applications need programming interfaces, more programmability in the hardware, right? So if suppose you had deploying any modern application, SaaS application or PaaS application or infrastructure as application in your data center, those devices must be supported programmability, right? So that's very hard to re-enhance these programming interfaces in your existing infrastructure, right? Second challenges is functionality wise. So currently, if you have like we are facing a lot of challenge with the spanning tree protocols. If you have tens of interfaces between access to distribution layer, half of the interface are getting blocked because of the spanning tree, right? Then you have the static configuration. For each and every task, you have to do manual configuration. By default, all traffic will be allowed. That's another challenge we have functionality wise, right? So if you want to protect anything, you have to do manually in the analytics infrastructure. And fourth is coordination between the network and server team. So this legacy infrastructure, if you are deploying, you have to have the multiple team which manage these infrastructure separately. There must be core team which handle usually L3 routing. If you have the uh, security devices in a distribution layer, core layer, there is security team. If you have the server infrastructure, you must have a server team, right? So these are the some challenges nowadays legacy infrastructure uh, faces. So what we are solving here? Okay, so Cisco ACI is application-centric infrastructure, which is the software-defined network built on the Cisco 9000 platform, Cisco Nexus 9000 platform. So this is the update. This is the hardware which support the SDN part. Okay, where we are decoupling the control plane and data plane from each other. Okay, using the modular devices. It's a two-tier architecture, leaf and span architecture, where you have the policy controller. So entire fabric will be controlled by the just three policy controller. So you do not need to log in individual devices. You do not need to maintain individual devices. You do not need to worry about the fabric between leaf and span configuration. All the things will be managed by the centralized policy manager. So policy manager, when I say it's a Cisco AP. So APIC is not a control plane, neither a data plane. It's just a policy manager. Control plane, data plane will be spine devices. Okay. What we are solving using the Cisco ACI here. The first thing is what we had challenges in a existing infrastructure, legacy infrastructure. We had issue with the management, we had issue with the functionality, right? So in the terms of the management, we are managing entire infrastructure, whether you have 10 switches, 100 switches, 200, 1000 switches, all can be managed from single interface. Okay. And all configuration can be exposed via the API. Switches join fabric in a few clicks, right? It's a you can say plug in play kind of stuff. You just bring your new device, connect to the spine switch, APIC controller will automatically discover your entire fabric, and it will push the basic default configuration on your switch to form the neighborship to bring the device up. Right? In the functional device, there is no spanning tree between leaf and spines. Since why no spanning tree? Because between leaf and spines, connectivity will be totally L2, L3 base. It's L2, L3 base. When I say L2, it's a data plane. When I say L3, it's a control plane. So that's why we call that decoupled data plane and control plane. So we run MPBGP, EBP, and VXLAN between the leaf and spine, which is by default running protocols. You do not have control over it. You can just tune the basic configuration of it. By default, VXLAN run between leaf and spine switches. You do not really control that VXLAN feature. So why VXLAN feature? The moment I say VXLAN feature, it means you're enhancing your infrastructure for the programmability, for better mobility. These are the some basic factors which ACI provides you. Second thing is dynamic configuration. Between leaf and spine switches, as I said, it's going to be dynamically configured from the APIC. You do not need to worry about leaf and spine configuration. You just plug in play, everything will be up and running. You just bother about the southbound interface configuration of the leaf switches, not the northbound interface. Okay. This is how the uh, this is how the communication works functional device. Right? We have the device to device communication based on the overlay, which is the VXLAN. So each devices will have its own type address, and they will form the neighborship with each other using the ISS PGP and provide you the one hop communication. It means if this server want to talk to this server, the bare metal server will initiate the traffic. You will go for the spine switch. Spine switch will already have that awareness through the MPBGP ISIS protocol, and it will redirect your traffic to the hypervisor here. So everything is centralized managed, and ACI also support the anycast gateway for anything, any traffic, which we call the bridge domain. So if you're creating the VLAN 10 in ACI, it's not the something which you are creating VLAN 10 for one particular leaf. If you are getting VLAN 10 going to be the any cast. It means VLAN 10 you can use in anywhere in this particular fabric. It means suppose you created VLAN 10, 20 here, right? So VLAN 10 and 20 will be globally available in the fabric. Okay, it's not like we are creating VLAN per switch space. No, this is not how the ACI works. Unlike the legacy infrastructure where you have to create the VLAN per device basis. If you have anything creating the policy here, that will be available globally. It means any devices can use. They are free to use that particular service. Okay, that's why we call that any cast services here. Okay. Why Cisco functionality wise, a layer 3 network running between the ISIS, a layer 3 network running ISIS is configured automatically by the your Cisco APIC cluster. As I said that to provide the underlay routing between leaf and spine switches, user does not have to understand and build the underlay. So if you suppose you are the new engineer in the infrastructure, in the networking, right? You really don't really should know what is running, or you do not really need to know what is running between leaf and spine for the underlay perspective. Of course, for our overlay perspective, you should have understanding. But for underlay perspective, it's a by default nature. Even you cannot modify anything. You just tune that just your timer, hello timer, or a hold down timer. That's it. You cannot touch underlay. You can just verify the commands. That's it. Okay. For a overlay network, it's built using the VXLAN to allow the L2 switching across the fabric as well as per VRF route the fabric across the fabric. User does not have to understand how to build the underlay overlay. Okay, so this is the simply this is the ACI SDN beauty. It means everything is simplified. You do not really need to know between what is running between leaf and spine switches. You just plug and play. It means you just connect the infrastructure between, you just provide a connectivity, physical connectivity between leaf and spine and Epic. Epic will take care about everything by default. What you need to really know that how you're gonna communicate the southbound interface. Okay, like this one. If I say that between leaf and spine, this one, all will be done automatically. You really do not need to worry about the VXLAN. You do not need to worry about the ISS protocol. You do not need to worry about the BGP. Everything will be by default will be pushed by the Cisco API by default. These switches will automatically get the IP addresses. All the things will be done by the Cisco API. You just need to bring up the your fabric. That's it. And for these interfaces, southbound interface, this is the northbound interface. Okay, so for southbound interface, you must configure that your configuration through the APIC. Okay, so you should only bother about this thing. Okay, if you really don't know what is going on between here and here, that's totally fine as far as your fabric is up and running. Okay, VXLAN uses VXLAN binaries are used to separate the L2 switching as well as the L3 routing. So I would suggest you to go to my channel and watch the VXLAN data plane and control plane concept. This is very important. If you do not really know the VXLAN, you cannot troubleshooting the Cisco ACI. That's for this. This is the basic thing. Okay, because VXLAN works with the control plane, which is MPBGP EBPN. It works with the data plane also with the ISS protocol for L2 traffic. So you really need to know that how the VXLAN works, right? What is the control plane? What is the data plane configuration? These things you should know that. So I would highly recommend you to watch my channel. Uh, Go to my channel and watch the VXLAN videos. This is the management perspective of Cisco ACI. So everything, this is the Cisco APIC controller overview UI interface. So everything will be visible through the UI interface. So Cisco APIC controller, you can access multiple ways. Either you can access from UI, you can access from API, you can access from the CLI. So this is the UI interface of the Cisco APIC, where you can see that all the how many APICs you have, how many leaf and spines you have, what is the health of these things, what is the if there is any fault, what kind of fault it is, what is the device health, all notification you can see from the dashboard itself. Okay, so there is a multiple like APIC can be in a cluster and must be in a cluster when you have the big infrastructure. If you have testing environment, it's not required to have the APIC interfaces. If I give you that APIC interface, so this is the APIC I have. This is the APIC interface which I'm running. If I go to here, I go here, it's a bit slow. This is the CLI. You can access to the CLI either. Okay, this is the CLI. If I share here how many devices we have, okay, so how many devices we have? We have two spine switches, two leaf switches, okay, and we have multiple APIC controllers, which you can, if I show you that, let me cancel this. If I go to this is the dashboard of the Cisco APIC. It means you will see that all the health are here. You can see how many APICs we have. We have three APICs. They are in the cluster. What is the health of this? If I go to one of the APIC, and this is the IP address, so all the settings, all the things like what was the historical data, so you can check the historical traffic here, what was the score of the fabric, and if there is any error, critical error, major, minor, or just notification error, warning error, you can check all these things from the centralized controller interface. You can configure entire cluster with your this APIC controller. This is the where the Cisco APICs are connected. So as I showed you that in the topology, so this is how APICs are connected, right? This is how they connect. We connect your APIC with the leaf switches. We do not connect APIC with the spine switches. Okay. So this is the UI interface of the APIC. If I go to next, so this is the health section as I showed you. This is the health section where you can monitor all the frame, all the minor major errors of the fabric. And this is the issue. If suppose you have any fault, you can exactly pinpoint that at what time this issue has reported. So you can check that from the historical data, and you can from the timestamp you can say that. Okay. And this is the how you can check the topology of Cisco ACI. So if I go here, show that what is the about topology. So centralized through the APIC controller, you can manage entire thing. I said that you will even have the visibility of the entire infrastructure. It means you can see that how many devices. These are the spine switches. What is the model number? If you go there, and what is the name of it? What is the serial number? What is the CPU, RAM utilization? What is the fault tolerance? Everything you can see that. If you have big infrastructure, it's going to be the big here. Okay. And Cisco AP is the UCS Cisco UCS servers, which come with the Cisco APIC OS. And these leaf switches are Cisco 9000 switches. The spine switches are Cisco 9000 switches with the ACI mode. Cisco 9000 switches has two mode, Cisco ACI and NXOX mode. So in order to enable the Cisco ACI, you make sure that you should have the Cisco ACI image on these Cisco UCS servers and these leaf and spine servers, spine switches. Okay, so this is how you can check the topology, like which switches are connected to where, what are the purpose of these, all the things you can check here. Okay, so which interfaces are connecting to where, all the things can be checked here. Okay, if I do the APIC policy controller, so as I said, this is the Cisco APIC, Cisco CCD server UCS CC20 220. So it has multiple management. So this is the CIMC port, which we use for the initial initialization of the Cisco API. Like when you configure that image, when you upgrade that image, when you make this Cisco UCS as a Cisco APIC, you configure through the CIMC interface. Okay, these are the management interface which can be active standby. These are the two ports which will be connected towards the Cisco leaf switches. ACI leaf switches. And these are the cards. So see, these ports can be copper and fiber based on your requirement. If these switches are copper switches, you can order Cisco APIC with the copper ports. If you have the fiber, you can use the fiber ports. Make sure that this leaf and spine, this connectivity should be with the 10 gig interface. Okay, this interface must be 10. This is the prerequisite. This interface can be 1 gig. It's not it's like you do not really require 10 gig interface for this management purpose, right? And this is how your outer band you connect toward the leaf and spine switches. You just connect any of the external outer band switch with the OOB port of the leaf and spine switches. Okay. So if I talk about the how you initialize your APIC, so this is how you log into Cisco CIMC interface. Once you bring that, once you take that controller with you, you just log into CIMC port, and you can see that this is the CIMC interface of the Cisco APIC, and you can check all the model number, all the versions, what is the Cisco APIC model. You can check that here. What is the UUID, all the health details. So this is just a server node level health check. Okay, this is the hardware diagnostic interface for the pure Cisco APIC. And in order to configure the Cisco APIC, you must have to configure through the KBM interface. So what is the KBM interface? Keyboard monitoring interface. Okay, so like In order to, this is the kind of console interface you can see that. In order to configure the Cisco APIC, in order to make that initial configuration of the Cisco APIC, you must configure that through Cisco KVM console interface. Without console interface, you cannot configure that, initialize the Cisco APIC. Okay, while configuring that console interface, while configuring the Cisco APIC to the console interface, you have to specify what will be your out-of-band management for the APIC access. Because based on this access, you will be able to access the Cisco ACI, Cisco APIC UI interface or SSH, whatever you want to do. Okay. Right, so this is all why we need Cisco ACI, and I would also like to go into the more in depth. So if I go to here, I would not really benefits. Let's go to the benefit. Why we are getting the what we are getting the benefits. Okay, so the data center is both. It can support both physical and virtual environment, and it provides you the enterprise scale and performance. It kind of meet the enterprise requirement with the nowadays modern applications, because modern applications are required a lot of bandwidth, lot of throughput, lot of programmability in the hardware, which ACI is meant to design. ACI has been designed to support these modern applications, modern complex infrastructure, modern complex requirements, best highest level of the performance. Okay, and it has a policy model. This is ACI is a policy model, policy driven sort of ecosystem. You can say ACI is not just a product; it's an ecosystem. I would say that. So Cisco ACI is a pure policy model based fabric where you all the configuration you can configure through the policy controller, which is Cisco API. And it it also supports the automation in the fabric for the both virtual and physical infrastructure, okay, through the API interface. So for approach, so this is how the Cisco ACI and what Cisco ACI is providing to us. Okay, initial days we had white box switching, when we had traditional switching, where we have integrated hardware software switching. Then we had virtual and overlay, where we had VM mobility, SDN LAN emulation, VM policy, uh, VM based policy. Now Cisco came with the unique type of ASICs, unique type of approach. You have They came up with this one inbuilt inbuilt kind of infrastructure where they build these all the policies driven model in ASIC label itself, and they include it in the software where they have common policies model, where we have physical and virtual environment, where we have secure workload placement, where we have application visibility health metrics, we have option for scale out, scale in, where you can have the full fabric automation, and it can be, it's a network, it's not the network emulation, and it's an open architecture. It's not like this is something property to anyone. It's open architecture. You can use any kind of architecture with the ACI. Okay, what is the, if I talk about the what we are getting here from the network, okay, it's simplified the single architecture performance, both the overlay, underlay, everything is one hop away. It means leaf and spine. We are totally eliminating the thick tile architecture where we have core switches which are totally meant to be for the routing. When we have the distribution switches where we used to configure that our R2V products and the gateway of the in-host, right? Then we had access switches. This makes your infrastructure very complex to troubleshoot, manage your infrastructure, right? So two-tier architecture is everything is all the core switches, all the distribution switches, all the access switches, everything is leaf and spine. Okay, there is no more complexity here. Okay, so it provides the benefit of the SDN plus policy without complex separation of overlay and underlay. It reduces the complexity and add operational simplicity in the infrastructure, definitely. So also it has a distributed fabric intelligence which reduce the engineering. Pre-architecture is already there, pre-validation is already there, pre-hardened is already there. What the meaning of pre-architecture? It means for the leaf and spine connectivity, you do not need to design anything. Leaf spine architecture is pre-built. It has pre-validated through the pre-configuration. It has pre-hardened it. It means by default is everything is whitelisted. So between leaf and spine, architecture will be same no matter which and where we are using Cisco ACI. You can change the architecture from the leaf to other devices for outside, but between leaf and spine, architecture is pre-built, pre-configured, pre-validated, pre-hardened. Okay, we have fifth advantage of it, optimal traffic forwarding. Okay, so location independent forwarding. It means it, as I said, that whatever you are creating the policy, it's going to be the present global. So you do not need to worry about the policy location where if you are creating any policy, that policy is going to reside in one switch. No, this something is old school concept. Whatever we are going to create, everything will be present globally. Okay, we have congestion monitoring through the APIC. If anything happen in your infrastructure, everything is premeditated, and we have predictive monitoring system where APIC notify that okay, this is the congestion traffic which you are, we see that, take the action of that. Okay, then we have flowlet switching. Then we have fabric load balancing. For ECMP, there is no STP spanning tree concept. So there is no active or blocking ports. Everything will be active. We have anycast gateway. It means if you are creating one IP address or one endpoints or one IP address which will be present across the fabric, right? But the meaning of it here is, if suppose you create one gateway here, your gateway here. What are the Anycast gateway? I would highly suggest you to watch my VXLAN video. So if I create VLAN 10 here, okay, if your VLAN 10 host is here, one VLAN 10 host is here, you do not need to worry about anything. Both the switches can use the same gateway. This is we call the Anycast gateway. This means everything, any switch can consume that gateway, can consume the VLAN 10. Everything is centralized. Okay, there is nothing specific to leaf base or spine base. Okay, we have in the terms of the monitoring, full time or real time visibility. We have the network level visibility. We have uh, tenant level visibility. We have application level visibility. We have atomic counters where you can see the real traffics and real counters in the infrastructure. Okay, what is the scale out? So it's a penalty free and low latency fabric. So we have delay between the ports is a less than 5 microseconds latency between leaf and spine ports. Okay, we have inherent inherent line card stateless firewall feature. We have line rate L2 L3 services, which is implemented at the leaf level. And we have line rate VXLAN integrated overlay. It can be support up to 128,000 endpoints. It means 128,000 servers can be connected. Server server means it's endpoints. Endpoint means users. Okay, and 6,000 physical server can be connected. Okay, which is huge number. So we have declarative policy model is highly scaled compared to the imperative SDN module. We have leaf and spine, which is a penalty free fabric. Okay, this we should talk about the policy driven. As I said that we have a restricted policy model based application requirement. So it declares the policy on the scale control of the intelligence objects. As I said that, so if it, it is providing you the common policy for your entire infrastructure. So if suppose you have three endpoints and they want to talk, for example, so it also ACI also provide the whitelisting model kind of. It means any to any communication will be blocked, unlike the legacy network where you have if two hosts are connected to the access switch, and they are in the same VLAN, which is VLAN 1, they can talk to each other, right? Without any complex, without any configuration need, without any gateway need, based on the L2 communication. But in ACI, we do not have that concept. If we have two IP, same subnet IP sitting in the same ACI fabric, same IPG, they cannot talk to each other without the contract, without the allowing the traffic. Okay, we have infrastructure operation as a single system, providing to the connectivity and services based on the application definitions. So as I say, ACI does support network-centric approach as well as the application-centric approach. Every software and hardware component is a programmatic object here. Okay, so policy integrated, not bound, and automation tool. For example, OpenStack, southbound for third party. So there is no such a restriction to use the API interfaces to make that infrastructure faster. And Cisco APIC can be can manage both physical environment and virtual environment. How does it work? So a single fabric with the seamless support both of virtual and physical workload. So no requirement for declaration dedicated gateway to integrate the physical and virtual world. So Epic, if you have the Cisco like VMware infrastructure where you want to integrate with the ACI, so if you do not have any server or VMware team, you can manage your entire virtual environment through Cisco APIC itself. Okay, you just have to make that enable the package. You have to just enable the package in a Cisco APIC. APIC can control your virtual environment along with the Cisco ACI, where you can configure the VLAN, BDS, and you can configure the policies and push into the vCenter and BDS switches. Okay, we have consistent policy enforcement across all the workload, irrespective of virtual and physical environment. We have agnostic to the hypervisors, where we support EXXI, Hyper-V, KVM, Linux, all the kind of hypervisor it does support. And we have agnostic to host-based encapsulation, which ACI does support VXLAN by default. It can support NVGRE, which is again is a VMware VXLAN. We have the VLAN-based concept. So ACI is compatible with all the physical and virtual environment with all the protocols. Okay. So in terms of the visibility, so by default, Cisco APIC monitor all the traffic. Okay, but it also allow clients to integrate their on-demand health monitoring tools like Hadoop, like the Microsoft Exchange and ETCs. Okay, so we have fully infrastructure visibility, single point of trust, health score per application tenant you can capture, where you have application-centric telemetry, we have self-documenting network fabric, real-time hope by hope visibility you can get, and you can get that detailed information about performance of individual endpoints. Suppose if you have endpoint 1 to A to B, and you want to capture the latency, packet drop, traffic path, or all the levels of information. What is the latency between we have in legacy infrastructure? In order to get that details, you have to enable a lot of features. You have to integrate a lot of tools to capture it. Where in ACI, we are getting all these features inbuilt with the Cisco AP policy controller. We have fully workload discovery and mobility. We have availability and performance business reporting. Okay. These are some enhanced feature which Cisco ACI provides. So what security we are getting here? Okay. So the entire ACI security is just give me a second, guys.